Yo, all right. So, wait, display isn't displaying. Give me a sec. I think that should be working now. Okay. All right. Cool. Now, it's already like pretty late, but I just want to do one Leetcode problem today because I didn't do any yesterday. Got to keep on that streak, you know what I mean, of at least one every 2 days. Okay, well, to do that, we will have to continue where we left off with, what was it? It was, what was it? We'll see. Right, let me open this up. So, Leetcode, practice, line 75 of the graphs, graph valid tree. Graph valid tree was the problem that we wanted to solve. Now, I remember I was looking at the solution, or I was reading through the solution, so I might just continue like that, revisiting the solution. But I want to see how I've done it so far. So given n nodes labeled from 0 to n minus 1 and the list of undirected edges, each edge is a pair of nodes. Write a function to check whether these edges make up a valid tree. So an example is n is equal to 5 edges, okay, right, all of those edges. And it's a valid tree because there aren't any cycles, I believe. All right, and this is not a valid tree because 0 to 1, 1 to 2, so 0, 1, 2, 3, and 1 to 3, which makes it 3 to 1, which means that you can have a cycle there. And 1 to 4 is fine. You can assume that no duplicate edges will appear in edges. Since all edges are undirected, 0 to 1 is the same as 1 to 0, and thus will not appear together in edges. Okay. And so my thinking was to use an adjacency list where we initialize all the possible nodes to having an empty list. Now this empty list is the destination from the key source or from the index as our source. And they go both ways, so it's not really source destination, right? But I guess you can call them node 1 and node 2. It might be a better, more suitable name. So n1 to n2 and n1. Oh. N2, okay. And we're saying these ends are just like nodes 1, node 2. Okay, visited set. This visited set, it's a visited set. If at any point you find that the node that you're visiting is in the visited set, then you don't want to continue. So if node in visited, you want to return false. Now, if you return false in the DFS, then you would return false. For a neighbor, nay in adjacent node, it's just for every neighbor. If that neighbor, DFS, you return false. If that DFS doesn't return true, and so you would remove the node, you would return true. For node in range n, if not DFS of node, then you would return false, and then you would return true. However, again, why don't you just add visited again? So it's a little bit confusing, because why won't you say visited dot add the node here, and then visited dot remove the node here? Would this be what I'm missing? No, it's not what I'm missing. There's something else to this. But I feel like I'll be on my way there. It's just also a matter of how. So let's try and consider, right? Each of these edges. You'd have 1, 2, 3, 4. And you'd have, for 0, you have 1, 2, 3 inside the adjacency list. And you would have only 4 inside this adjacency list. All right, so maybe let's build out an adjacency list. Now, I'm going to open a new tab for graph valid. Okay, apparently it's not here. Valid tree. Okay, valid tree. Why isn't it? Why did I call it? Okay, right. So anyway, graph valid tree is what it's actually called. And we're going to have to create a new drawing. And we'll just think about it. I'm going to draw it on my iPad. Ooh. Things will have to load. See, this is called just got to reopen it. I'm just going to wait, and it's going to sync up. It's just got to sync up. Hopefully it syncs up soon. Is it done? Maybe. Maybe. No. Is it still doing stuff? Yes, it is. Okay, it's doing lots of syncing now. Good. Okay, just let this finish syncing. I'm going to go to validate graph tree. So we created this new note. Going to add it as drawing, just like that. And we're going to go directly to this and then just draw this problem out. I will turn down the brightness on my iPad. So for the problem of 0, 1, so ADJ, ADJ is equal to, now in this scenario, I'm going to have a list for 1, 2, 3. 1, 2, 3. We're going to have a list for just 4 inside. We're going to have, actually not just 4, it'll have 0 and 4. All right. And then we're going to have 1, 2, 3, all having 0. So this is for 4. And this is for 1. We had it for 0. We had it for 1. And we go to 2. We have it. Okay, 2 is just having a 0. 3 just has a 0. 4 just has a 1. Right? Okay. Let me go back to this screen. This will update. Okay. So that is what our adjacency list from our implementation looks like. From here, what can we deduce? So let me see. From the 0, let me see. Oh, hello, Nuffy and Rio. Real-time caption. Oh. Oh, wait. Oh, your audio. Okay. Is real-time, wait, is, okay, okay, right, real-time caption, okay. Yeah, no, we do have captions, but we don't have real-time captions. All right, yeah, now I get it. Yeah. That's true. Okay, well, how do we go about this? If you were to do a search through it, graphically you would have, what, node 0, node 1, node 2, node 3, node 4. Node 0 points to 1, I guess 1, 2, and 3, and 1 and 4. this is enough to tell me that it's a tree because there are no cycles. It's really a matter of cycle detection. But say you start from 0. Would you have to check every... You would have to check every node, right? You have to check from every node if going down the tree will lead you in a cycle. And that means the visited set will be kind of reset every time. So after you've done it for 0, so the visited set for 0 would, after processing all of 0's DFS, would be 1, 2, 0, 1, 2, 3, 4. And that would be it. So in this case, it's like the visited set. It's a key. It's somewhat of a keynote that the number of nodes in the visited set is equal to the number of nodes only if there is no cycles. Now at 1, you would see 0 and 4. But you don't detect any cycles. At 2, you would have 0, 1, and 4. Hold on. 1 you can get 0 and 4 and 2 and 3 as well. So in that case, if it's undirected, does it mean that you could start from any node? Because it's undirected, you can start from any node to reach every other node. And if the final n is equal to the length of the visited set, or the magnitude of the visited set, then that would return true because it is a tree. But it still begs the question that, okay, well, that means you can kind of start from anywhere. You can start from 3, you can start from 4, you can start from 2, you can start from 1. And if at any point during that search you reach a cycle, then you won't do anything more. Okay, so I mean, to me then it seems that you can start from anywhere and you don't need to check everything, like what I do in this last step, right? So my thinking is then that you just do DFS of node, where node is, actually hold on. Yeah, all right. So get rid of that, get rid of that. See. DFS of, literally you can start it from anything, seems to me. And you would return what that would give you. So you would return true. You would return false. See, so DFS node, if node in visited, return false. you now add the node. If it's not in that, and then you would check the others. Now, if any of the DFSs returns false, then you would return false. And then if you've done all that, none of them returns false, then you would know that every subproblem has worked and you would return true. But that's assuming that adjacent node. Okay, let's have a look here. So if you do from, say, 0, right? You do it from 0, you get if 0 is invisited, it isn't. You add 0 to the set, and now the set has 0. For the neighbors of 0, you have 1, 2, and 3. If not DFS, so then you do the DFS of, say, 1. From here, though, you would say add 1 to the visited set. And then you would go down 4, which is the only neighbor. And 4 is not in the visited set, so you would add that also. And then 4 goes back to 1, which is not what we want, because that's what's in that. So if if neighbor is already in visited, is that what we need? If the neighbor is already in visited? If the neighbor is in the visited, you wouldn't go down further, but it would mean you never detect a cycle. So you need to keep track of what the previous node was, I think. Hello, George Vell. Topological graphs, nice. Yeah, I mean, I'm learning about it. I'm doing it through cycle detection. I don't think this one necessarily needs topology. Wait, like there is no topology in this because it's undirected. Is that right? Is that the right assumption to think about this problem? I hope it is. Unless it can be generalized. But next gaming, hello. What question number is this? This is, and let's see. Oh, it's a subscribe to unlock. So I believe this is also doable on a different platform, but it's all right. Isn't cycle detection existent in topological graphs? Maybe. But this is from just doing one of the graph problems last time, where I did have cycle detection and topological sorting both as possible solutions. How would cycle detection actually be existent in topological graphs? I don't think that I can wrap my head around that yet. I have to see an example. Regardless, my thinking is for this problem that we need to keep track of the previous node that we were at. So if it was the previous node, then we would prevent that undirected cycle straight away. And if that's the case, we'd probably need a prev node. And this means that we'll need the current node there, and we would maybe put none here. So if nay is equal to prev, then you would continue. And so then that means you would have nothing and you would return true, and then that means the result of 1 the result of 1 would mean you go to the others, but there is no others, so you would return true. You're at 0, you would check the next. Yeah, so yeah, you would check the next, and you go again, check the next. Okay. I'm gonna try this, we'll see. Okay. Okay, output return true when you expected false. Okay, yeah, because you don't, because this is completely split. You have to check that the final visited set is equal. So this and visited is equal to n. Oh, sorry, length of visited is equal to n minus 1. Oh, okay. Let me think. What is n minus 1 here? And what is visited here? It's an empty set. It's an empty set. Why? Visited dot up print visited oh, true. Actually, this does happen just, okay, after. What's the question? I mean, it's a Leetcode problem that's hidden. But this is the problem. Pause it if you wish. Oops. Actually, I can just keep it here. That's fine. I guess it just has to be 5, doesn't it? Yay. Okay, well, okay. We're fine. We figured it out using cycle detection, using a previous node into the DFS. But could there have been any other way around this problem? All right, so is this basically the same? If len of edges, what is edges here, is greater than n minus 1, why does that, what does that mean? You're telling me there is a situation where the number of edges is greater than, right. So if the number of edges is greater than n minus 1, then there has to be a cycle. Wow. That is fair. That is fair. You have a point. That is a good point. However, how does that tell me about anything else? Anyway, visited set, DFS, node prev. I don't know what the par means there, but that's fine. The neighbor, adjacent, this looks basically what I wrote. This looks like basically what I wrote. This is literally basically what I wrote. Okay. But this first part is, I guess, just for an efficiency, an optimization. It's just that, how can you assert that? Oh, Nahi. Did you change something? The graphics look way better. I don't think I did. Although I did set up my laptop screen, so I actually have a laptop screen. I did that because yesterday or the day before yesterday when I was streaming, just on my laptop, there was like black bars on the side, but I don't think that should have affected what you currently see now. Yeah, maybe something did change. Rec script, hello. How you workflow generally work? I am trying to learn and practice code. Can you help me? Well, generally how I do it is I just follow a policy. All right, just remember this policy. If you read the question and you get, after you've read the question and you're doing the question, but you get stuck for more than 5 minutes, look at the solution straight away. And then after you've seen that solution, write a few dot points summarizing what you learnt from, say, the video solution that you saw. That is all you need to do. How you do it, using pen and paper, using Obsidian, like what I'm doing, that's all entirely up to you. Did you start your internship? I have not yet. It is starting next month, early next month. So we're still talking like 2 weeks, less than 2 weeks before we start. But yeah, it's going to be exciting. It's going to be exciting. RecScript, you mean Obsidian and learning new language and practice Leetcode. Let's say you're learning a new language, JavaScript. Well then, that's a good question. Learning, say, a new language, any of the concepts, say like when you're typing syntax, anything you don't remember syntax-wise, I would jot down, almost like document it for yourself in, say, Notion or Obsidian. You know, that's how I did it for learning how to do a heap, like how to set up a heap data structure. You know, I've sent this in our Discord, but it's the boilerplate code. So boilerplate code as in like the pseudocode of kind of what I would, it's not pseudocode, but yet it is kind of like pseudocode. But it's the code that I'd be writing to build, say, a depth first search, for example. Something like that. I don't know, hope that answers your question, Rex. How many Leetcode questions you did? It's about 80 now. 80 to 85. I take discrete math next semester. How was it for you? We didn't have a specific discrete math subject, or at least I didn't do a specific one. What we did instead, or I don't know if it's really an alternative for discrete math, but we did, at least what I did, was linear algebra, Calc 1 and Calc 2, calculus, and a vector calculus. Those were the subjects that I took for my math because, you know, at the time also, you gotta remember that I did my bachelor's in pure math. So I was going to do my bachelor's in pure math. Hopefully, yeah, so I don't know. We didn't really do discrete math, or I didn't. Which is ironic, having me done pure math in my first 1.5 years at uni. Hello KFC. You have cut your hair? Yes. Thank you. I appreciate it. And welcome to the stream again. It's been a while. Discrete math is hard. We jump through so many topics, you don't get a chance to really practice. Yeah. That's with a lot of math courses, to be fair. You know, like there are so many like problem sets that you can do as well. It's just so much that it's overwhelming. And if you have 4 subjects in a semester, it's even harder. I will agree with that. Do you think school matters for SWE career prospects? Yes and no, depending on what career or what company you're looking to join or you're wanting to join. For any of the high frequency trading firms, we're talking like Optiva, at least in Australia. We have like Optiva, we have Jane Street, we have IMC. So these are all Australian, I believe, or at least Jane Street's global, but they have something in Australia. Those companies, you need to have good, scores in school. And, you know, the reward is you would probably get paid, say 1.5 to 2 times more than what a software engineer would. So if that's part of what you want, that you might need to really work hard for it, but Some of us might not really be that good. But also some of us might have just started off on the wrong foot. But even still, you don't need to be a SWE role is still a lot of money, and you can climb the ranks and get more that way. But also, personally at least, I don't really condone or like high frequency trading firms. Not to say I won't take up an offer from it, but personally, like, if you're high frequency trading, it's like that's the only value you bring to the world. You just literally take money out of the market. You know what I mean? At least Google, at least Amazon takes your data, but also provides some sort of value back in a sense. But look, maybe I'm still naive. Maybe I still don't know exactly what's involved in the HFT or what's involved in big tech. So we'll definitely see when I get to talk to people in all the different respects when I'm at Sydney, and I'll maybe relay it to you guys. The most disappointing part of my current undergrad is that you get no actual time to sit on material and delve deep because of the amount of material. Yeah. Nah, George, I get you entirely, man. That's exactly how I felt as well in my undergrad. I'll take money off the market if anyone wants to give it away. So Ding, can I ask how to get out of basic zone? What do you mean? What's basic zone? As in your basic understanding? Am I dumb for wanting to switch from online college to a traditional? The online is super affordable, but I don't know how it would look on my resume. I mean, it's a valid concern, right? The biggest concern is of wanting to, I guess, like making new friends along your journey. Because I feel like when you're online, it's probably harder than, having physical interactions with people or joining clubs and speaking to, people who are also doing your exact degree. I guess you just need to put more effort if you want to go with, if you are doing online, you want to probably do more effort in, reaching out to people, speaking, joining clubs, even if it's like a club near a uni that you're at. Maybe there's a uni near you and there's a club for computer science there. Maybe you can join that local club, but you also work and study online. But yeah, I would recommend just trying to find like-minded people, and that is the biggest benefit from traditional study or traditional, college education. The other thing was personally, here's another thing, right? I'm saying this in retrospect to my own experience in my bachelor's, where I didn't, even doing a traditional college degree, I still didn't make the effort to go out to clubs, or go out, not to clubs, but not to nightclubs, but to events from uni clubs. And, in retrospect, I actually do regret not having done that. So that's why my master's, I am doing this now. And we're talking, it's, my first year again, technically, but for my master's. So I'm technically considered a first year. And, it's kind of like a fresh start for me, I think about it that way. Anyway, that's beyond your question now, I think. Would you prefer working in US or Australia? Personally, I would. like to stay in Australia if I can, but I am open to working in the US. It is definitely going to be somewhat interesting if I do. It'll be a lot more new people, and I feel like it'll be nice. It'll be nice. I feel like I would make more money, but also I'd have to live in America maybe. But I don't know. We'll see where life takes me. We'll see what opportunities arise. But I wouldn't say I prefer one over the other. I don't think I would. Despite me just saying a minute ago I'd prefer Australia. What the? Yeah, I am in Australia. If you didn't notice. Yeah, no, like it's light out right now. Like I'm sure in America it's probably getting dark now. But no, it's I live in Australia. Hello, Geary. Nice to meet you again, man. Hey, what music playlist said regarding like a holistic view of computer science as opposed to a deep understanding? I agree with that. Yeah, it's just somewhat unfortunate sometimes that maybe you want to learn deep into something, but you're not really given the proper opportunity to, unless, say, you go into research. But I guess it's a good skill to have to learn just the holistic view of computer science, because then it'll become helpful when you actually get into work. So I do say in retrospect, like, it's still beneficial to learn the superficial. Beneficial to learn the superficial. How are you doing? I am doing okay. I am finished with cycle detection. However, how any of these other algorithms work is something I got to look into. The problem is, so I did this so I can say here, I solved this problem using cycle detection, which is an O of V plus E, vertices plus the edges, time and space complexity. Is it space complexity? Is that, is it though? Maybe. I guess you can justify the vertices as being the length of this first list, and then edges is basically, 2 times the actual edges. In this case, we have 8 edges, but that's because that's directed, but it's 4 edges in reality. So space complexity wise, that makes sense, but time complexity wise, you would have to iterate through the DFS to each of the node children. You would need to iterate. So look, like the for loop here, you use a for loop here. To perform a DFS on a node and on the children nodes. But you still consider that many edges. Yeah, I suppose that justifies. That does justify it. Okay. Okay, however, I want to watch this problem, how he speaks about it, because I did get to a certain point here. Maybe I do finish my CS bachelor's online, then do a master's at campus. Yeah, actually, yeah, that's a good idea. To be honest, like, yeah, like if you've already invested so much time already in a online bachelor's, just continue until you finish it, right? Persevere, and then do a master's where, you know, again, you're going to be the most I guess knowledgeable one there, or like have the best foot forward for a master's. And yeah, at least you know, that was my case. I believe, like, personally, I felt more confidence after having done my bachelor's, and then just walking into masters. I feel like you should be more focused on honing your individual skills rather than headbutting to get straight A's just for uni. Though that's just me. Honing your individual skills. Okay, so I guess give me an example of what honing individual skills means. Because I believe you might be able to do both at the same time. That's just part of what I believe now, but maybe explain further. If you want, that is.
Hey everyone, welcome back. Value, every single graph is going to have at least a node 0. If we don't even have node 0, like if the number of nodes, if we don't have any nodes at all, then we can return true. Basically, an empty graph does count as a...
Also, actually, with this problem, if I change this 0 to... Ooh, but it always has to start from 0, doesn't it? It always has to. Not because it's bad to, but because you can always assert that you're going to have one node and it's always going to start from 0. Dang, fuck, that's why they use 0. That's why. Okay, I've got to write this down. We use 0 as our starting point because in reality, we can pick any of the nodes to start from, since this is undirected, but we don't assert that any of the other nodes will exist apart from the 0 node. Because of the assertion in our question, because of the constraint in our question that 1 is less than equal to n is less than equal to 100. Right? I agree. Cool. So yeah, I'm building a lot of projects and grinding school. I'm luck I don't work, so I usually at my desk 14 hours a day. I see. Yeah. Well, that's good. That but don't work too long. All right. Good, but don't work too long. Yes, like you can, but then it's going to be a race where you ought to compete even more. That for me, kind of, it's staying away from end goal. That makes sense. Wait, so yeah, like you can, but then it's going to be a race where you ought to compete even more. That for me kind of is like straying away from the end goal. I see. Right. I see what you mean, right. I've definitely thought about that as well. So for honing skills parts, It's just my way of saying one focusing on their end goal instead I mean that's what we want anyways, right? Because ultimately we know campus is just a big gamble. Yeah, so Nahi's question is also valid. So how is uni a gamble? Rio can elaborate, but to your first point there, Rio, actually, still I do know what you mean regarding it's straying away from your goal because you want to get, straight A's. But I also think that it's tough to say. Like for me personally, I've also had this thought in the past. But it's quite nuanced to actually even elaborate on what I'm trying to say here. If anything, I still agree with everything you say there, Rio, but there's something about it that I haven't articulated out that I'm just trying to think about still. It's always a probability of you getting selected or not based off your results. In selected in, say, what, job selection? Or do you mean, maybe the marking of exam scores? Like, what do you mean? It's an interesting question, though. Definitely I'm thinking about this for a bit of time. Because I feel like you can still have your study aligned with your end goal. That's what I believe, but maybe the situations that I'm thinking of in my head aren't necessarily the ones that you might have in yours. So some level of discussion is necessary here. Yeah, so what George Vell says is also a valid point. Nah, I don't know. Whoops. All right. Okay. Regardless, how does this breadth first search work? Actually, wait, let me watch this.
Technically. But so in this case, we don't have an empty graph, so we're going to start at node 0. What are we going to check? Basically, we're going to do a standard graph traversal. You could do breadth first search, but I'm going to do depth first search. And
breadth
so for
first
every
serve.
single node, we're basically going to go on and visit its neighbors recursively and then continue to do that until we visited every single node that's connected to the 0 node. At the end, what we're going to do is take the number of input nodes that we were given, in this case it's 5, and then we're going to check if the number of visited nodes matches. If the number of visited nodes matches the input value for nodes, that means every node inside the graph
Has
is connected,
been
right? That's one of the things
visited.
we're looking for is the graph connected? If the number of nodes we visit matches the number of nodes given to us, we can guarantee that the graph is connected. The other thing we're going to check for is
Epic.
to make sure that this graph does not contain any cycles or loops. If we ever encounter a cycle, like for example, we have an edge like this. If we went here, we went here, we went here, and then we got back to 0, that counts as a cycle, then we would have to return false immediately. But if we don't reach a cycle and this condition ends up being true, then we're going to return true. So since we start at 0, what we're going to do is to our set of visited nodes.
Honestly, I might speed this up.
Because that's the most efficient way to do it. So we're going to add that node 0 because 0 has been visited. So then we're going to recursively go to its first neighbor.
I just want to see if I missed anything.
And from the perspective of 0, we're going to visit 1. After we're done with that, we're going to visit 2, then we're going to visit 3. But first, we're going to start at 1. So now we're at 1, right? We're going to go ahead and add 1 to the visit set. And we notice 1 has 2 neighbors, right? It has a neighbor 0, and it also has a neighbor 4. Now, one problem with our algorithm is for every node, including 1, we're always going to want to visit every single neighbor it has. We know that the neighbor 0 has already been visited, right? So if we end up going back here, we're going to see, okay, we're visiting 0 again. 0 happens to be in our visit set, so that means we detected a loop. But technically, this graph does not have a loop. So how can we get around this edge case if every time we visit a node like 1, we're going to end up going back to where we came from, and that's
Just pass a previous node.
of detecting a loop. It's going to be a false positive for a loop. How can we get rid of that? Well, every time we visit a node such as 1, what we're going to give it is one additional value, and that's going to be previous. Previous is going to be what the previous node we just visited was. So when we get to 1, we're going to say
Yeah, exactly.
was 0. So we're not going to go back to 0 from this position. If there happened to be another way back to 0, for example, if 4 ended up connecting to 0, then we would detect a loop, right? But what if we ever got to 4, we would say, okay, the previous value from 4 happened to be 1. So this 4 came from 1. So we won't get any false positives if we do it like this. So from 1,
Am I missing anything else
in
from this?
neighbor 4. So yes, we're going to go to 4 now, and we're going to see, okay, is 4 already visited? It's not, so let's add it to the visit set. So 4 is going to be added as a node that's been visited. Now, we know the previous node from 4 happened to be 1, right? So we're never going to go back directly to 1. We're going to skip that, and we're going to check, does 4 have any other neighbors? It does not. So this is going to be our base case for our depth first search. We're going to return
Sure.
true, because so far we have not encountered a loop. So we can return true. If we did,
Sure.
then we would have to return false. But so far we're good. We're going to return, and then we're going to get to 1. And from 1, we have no more neighbors left to visit either. So then we're going to return back to 0. And by the way, what kind of previous value would we feed into 0? Because it's going to be the first value we end up. It's going to be the first node that we end up visiting. So we can give it a default previous value of -1 because we know that no nodes in the graph are actually going to have a value of -1 because they start at 0. So now let's go to the next neighbor.
Sure.
2. Okay, check, has 2 been visited? It hasn't, so let's add it to our visit set. 2 is being added. Now 2 does not have any additional neighbors. It only has that neighbor that it came from, node 0. So we're not going to keep going. And then we're going to go to the last neighbor of 0. We're going to go down to 3, and once again, check, has 3 been visited? It hasn't. So then we're going to add 3 to the visit set. Then we're going to go back to 0, and 0 does not have any additional neighbors. So now we're done. We didn't detect a loop, so that's good. But let's make sure that the graph is connected. So the number of input nodes we were given is always going to be given as a parameter. It was n equals 5. Now let's check the length of the visit set because that tells us how many nodes are connected, and it happens to exactly be 5, right? So in this case, we are going to end up returning true. Now if I change the graph and say this edge did not exist, of course, then we would not have visited this 3 node. Then the length of our set would have been 4, but the n value was 5. So does n equal 4 the size of our visit set? No, that does not match, right? So therefore, in this case, we would have to return false. We didn't detect a loop, but the graph is not connected, so we have to return false because it's not a valid tree. And similarly, let's say we had an additional node from 4 to 0. Then in our depth search, what we would have done is, okay, we have gone to 0, and then we're visiting 0. So we check, is 0 already in our visit set? Yes, it is. 0 is right here. That means we're visiting it twice. That means we detect a loop. That means we return false immediately. So that's the main idea of this algorithm. Now the time complexity, since we're only having to traverse each node once, at most once, and each edge at most once, the overall time complexity is going to be the number of vertices or nodes, so just e plus v. And that's also going to basically be the memory complexity as well, because
Alright, well, yeah, there is nothing much new from that.
every single node to all its neighbors. And I think it'll be, if it's not super clear right now, I think it'll be pretty clear once I show you the code. It's not too bad. Let's get into it. So one base case is if we aren't given any nodes at all. So if n was 0, so in that case we would return true. There's no graph to traverse, but an empty graph does technically count as a tree. And if we do have some nodes, then we're going to create.
Yeah, so what problem number is this? Graph valid tree. I'm just gonna find that. Whoa, sorry guys. Graph valid tree. Graph valid tree 261. I'm gonna just say, right? 261. Graph valid tree.py. And we're gonna copy this and paste. Git add, git add, git git commit value of graph. Okay, solved after second day of not completing the problem. Git push. Okay, we have added that now. We don't need to add it to the Leetcode one because, yeah, we don't know.
Adjacency list. So what I'm going to do is, first of all, for every single node in our input, so basically n is the number of
Hello,
nodes.
Kasahara.
So in range n, I'm going to create a pair in our hash map, and each pair is going to be the value.
Okay, he's going to use a hash map, sure.
And then I'm going to go through every pair of nodes in every single edge. So an edge is basically a pair of nodes being connected, right? So what I'm going to say is, and remember these edges are not directed, so they go both ways. So for the adjacency list of n1, I'm going to append n2.
Much of this I already know.
Similarly, for the adjacency list of n2, I'm going to append n1. And then I'm going to start defining our depth first search. Remember, we are going to have to know which node we're visiting, so I'm going to use I as the value of the node that we're visiting. Remember, we're also passing in one other variable, the previous node that we came from, so we don't get false positives for loop detection. And so you can see I'm defining this function inside of our outer function. That just means I don't have to pass in the variables like adjacency list into this each time. And actually, I need to define one more variable. That's going to be visit, which is going to be a set, which is going to keep track of all the nodes.
Visit
so
set.
If I is in the visit set, that means it's already been visited. That means we've detected a loop. That means we can return false. If not, that means I hasn't been visited. So then we can go ahead and add it to visit. So let's add I, and then let's go through every single neighbor of I. So every single node, let's call it j in the adjacency list. So the list of neighbors of I. And if j happens to be equal to the previous node, the node that we came from, then we're going to skip this iteration of the loop. We can do that with the continue statement. If it's not the previous node that we came from, then we're going to search on this node j. And as the previous value,
yo guys, I might want to try to some.
The return value of this is equal to false. So if not the result
After
of this, then
this.
we're going to immediately return false because that means we detected a loop. If this does not return false, then we're basically
Just to see if I can actually do it after all these months.
Return true, meaning we did not detect a loop. So we want to now return the result, right? And of course, we know we're going to have to call our depth for search function. We're going to start at node 0, and as a
To some, by the way, is a first Leetcode question.
What it's returning as the true and false is only detecting if there's a loop
In
like cycle or
Leetcode.
not. But it's not making sure that the entire graph is connected. So we're only going to return true.
Yeah,
if
to some
function
mentioned.
And if n, which is the input of the number of nodes, exactly matches the length of the visit set. Basically, every single node.
Alright, well, this is exactly the way that I would have solved it. Alright, I mean that I did solve it. But I want to see these other examples. So you're saying breadth first search here, but why? For sure, I guess you can. Yeah, I mean, instead of DFS, you would do a BFS. A BFS would mean that. So you can also, okay, let me write it here. So, adjacency list, graphs, DFS, BFS, and disjoint set union. Disjoint set union is interesting because we haven't talked anything about that yet. You can also solve this problem using BFS, of course. You just learned Git and Linux through the Odin project. It looked complicated at first, but it's so useful. I didn't know the Odin project did Git and Linux stuff. Damn. Oh, actually, Git stuff, yes. Linux stuff, no. Like, I know they teach you about Git when you're first starting out in the Odin project. So, for sure. For sure. Okay, disjoint set union. Now, okay, wait. Is there any part of this that doesn't make sense to me? Can I replicate this in the future? I solved this problem using DFS to begin with. Maybe in future you should try to solve this problem using BFS for fun. Right, and okay, disjoint set union. Let me think. Oh, PAR means parent. That's why. You're not bad. You're not bad at all. Not bad at all. Okay, but yeah, I mean the general structure of a queue makes sense. Like it's just basic DFS, BFS. It's fine. It's good. Okay, disjoint set union. This is going to be interesting. Union find. Union find. I did union find in one of my school capstone projects. Man, I wasn't really concerned with the code, but we did make a union find algorithm displayer, which we did in a team of 4, and those 4 people are, you know, close friends of mine now. Sorry, group of 5. But cool. Hello, Canal. I'm good. Just let's see if we can understand this problem. Understand this disjoint set union implementation. Now, what does this mean? V is the number of vertices, each is the number of edges. Alpha is used for amortized complexity. Amortized complexity, guys. I do not know what that is. Theoretical computer science. Hello, enthusiast dev. Okay, so Nahi, have you ever considered using Anki for these? I bet the spaced repetition aspect would be really helpful here. I have considered it, and I do have a Leetcode deck of questions on my Anki. Let me bring it up. However, okay, it's got Leetcode 150. Oh, it's literally got Leetcode 115 here. I did not think about that. Alright, I gotta eat dinner soon. But I didn't, okay. Hey, Nahi, thanks for bringing it up, I guess, because I didn't realize that this Leetcode deck would actually have the Leetcode 150 in it. I forgot, basically. So if I did this right now, right? No, let me do shit, what was the first one? It was arrays and hashing. No, give me one of the ones. Okay, anyway, it contains duplicate. I don't remember exactly what this even means, but okay. Contains a duplicate. I'd have to go to the Leetcode problem. Related topics. Okay, yeah. Okay, right. So I don't even know, because these problems are laid out this way. I would have rather liked insights, but I know everyone has their own different insights for each of these problems, so that's why you'd probably have to make your own Anki decks for this. I can probably like translate some of my markdown notes to Anki flashcards. Definitely, probably if I can use some like AI, like word processing to make Anki flashcards from my existing markdown, that would be pretty good. Something to consider in the future, but cool. Now, you thought 50 cards was a lot. I mean, this is pretty much all the Leetcode problems updated since maybe the start of this year. But no, these questions, you know, aren't mine. I didn't create these, right? It's just taken from somewhere else. I don't feel like there's anything else. Okay, well, let me close that. Okay. Okay. So, should I really understand this? Should I bother? Maybe I won't bother. Just with this one. So, you can solve this problem with disjoint set union, but at this point in time I have not fully understood or really want to learn this idea unless it comes up again in the future. As simple as that. Okay. Now I want to quickly, kind of do two-sum again. Okay, so two-sum contains duplicate was actually the first ever problem. So it was the way it is. Okay, I'm gonna quickly look at this. Maybe I'll have dinner before I even finish this again because I probably forgot how to do this problem. Okay, given an array of integers and an integer target, return indices I and j such that adding them equals the target and I does not equal to j. You may assume that every input has exactly one pair of indices. Yeah, okay. Return the answer with the smallest index. Let me think about this. You want to return I and j. So the output here is just going to be whatever I and j is. I need a hash table. That's all I can remember. And you can use a hash table, or perhaps you can use just an array, perhaps. I'm thinking it has to sum to the target. Okay, maybe you need to use a hash table. And maybe that table, when so given an array of integers and a target, for I in nums, or range of len of nums, nums I is this first number, maybe. Table of nums I, this first number, is equal to target minus nums I, perhaps. Now, if, this is from pure imagination, not imagination, memorization. At least this is somewhat what I remember that we did. We had to use target and we had to use the minus symbol. Is it possible then that this table, like what does this give us? This gives us the other number. So if this other number, if other in table, then j is equal to I. J is equal to I. No, we just return, or we just break. So then you get I there. Or should I say that, well, it doesn't matter in which order you return it in, right? Or is I always less than j? Maybe not. Table nums I. That's not it. Maybe it's just I. Let me think. If you just did table I, yeah, but what is other? If nums I in table, that's not it. In table I, no, that's not it either. It has to be nums I in table, I think. I'm just forgetting how this fully works here. Hello, Amal. The keyboard is tripping. It's tripping you up, maybe. Craziest keyboard you've seen, Rio? I'm still like learning this keyboard. I would say like I still don't fully utilize all the keys or fully use it well enough. I mean, maybe it's more that I don't use the I don't use Vim well enough, perhaps. I should say. Okay. You just flex your biceps and boom, question solved. I don't think that works. Not if you don't have big muscles, no. Unfortunately. Holy shit, that scared me. Sorry, that was the wind. It just closed the door really loudly. Let me close this. Don't need this though. Let me think about this problem. I in range. If nums in table. Right, so we're still saying nums in table. Then you're breaking and you're meant to keep track. Target minus nums I, the actual value, to get the other value. So if it was 1 as your number here, then it would equal to 2. If nums I, if table of nums I No, wait, let me think about this. If right, you don't want to put the target here. Alright. You want to instead put the value of your index. And maybe you put the target minus here. So then that table is taking if nums I in table, then you would, oh whoops, it's basically what I wrote already on top. You would break this is your J. If nums I in table nums I and I perhaps 1 0 when expected 0 1. Okay, bet. Let's go. We can do two sum with some proper thinking. With some proper thinking, you can solve two sum. Okay. Amal, so you're really confused on what tech stack should I choose to learn. Currently, I do just DSA on CPP. Can you recommend something? So much information on the internet, it confuses you. And then enthusiast does 2 loops, yeah. But that's not optimal. That's O of n squared. You need O of n. Amal though, I would say, learn any tech stack. Learn any tech stack. Pick the first one that you see on the internet. Learn it and just stick to it. Now, for me, here's the thing. I did think about this problem. Since I've already had previous experience at a startup before, I chose to pick something related to a fast API backend. And that's why I am learning a stack that is React, fast API, basically. And I'm using that to build my app that I'm building. But that might not suit you. I mean, if you're really just don't know what to use, maybe you should just use that. Because it comes with a template, or well, I took it from a template called Full Stack Fast API Template. Fast API, Full Stack. Yeah, so Fast API Template, Full Stack Fast API Template. This is what I used to build my app that I'm still building. And not too far from the baseline here that's already existing here. But it teaches you a lot about, the modern tech stack, I would say. And, a lot of this stuff I'm still learning myself. But it gives you an idea. But yeah. All right. Actually, I shouldn't close that. All right. That is it for now. I did two sum. I solved it without... okay. Actually, let me go to two sum. I have, so update as of 17th November. I have now solved this problem again without looking at solutions, and I understand to a better degree the reason why we use a hash table here. The main reason we use a hash table is to know what the other value is that we need to make the target value. Yeah, I can understand that. Okay, we're saving this. All right, guys. I'm gonna call it a day. Okay, but Rio, do you think it's just general knowledge of a particular PL we can jump to frameworks? Or do you need the PL all the way through the end? Oh, programming language. Right, let's see. Do you think with just general knowledge of a particular programming language we can jump to frameworks? Or do you need the programming language all the way through to the end? Oh, right. I get what you mean. Yeah, you just need general knowledge. You don't need literally like to know every single detail of a programming language. If you know, look, like if you know 80% of the programming language or 80% of the most used stuff in that programming language, you're fine. Like for me, if it was Python and I'm learning about fast API, you know, the 90% would be, or the 80% would be like learning about functions, how to build a function in Python and how to create classes in Python. And then that's basically all you need. But a general knowledge of those things, if you ever look into, if you ever see something new within the framework, you can just search up in the programming language, like what a data class is or what this at decorator is of a Python function. Something like that. At least that's my case. We needed to free memory as well. If it returned nothing, I might be wrong. I don't know what that is in respect to. Regardless, we're done. All right, I'm gonna go have dinner now. Thanks for joining in, guys. I appreciate you guys sticking along. I will, yeah, call it a day tonight. And that was basically all Leetcode problems. I didn't do any of the other parts that I wanted to say, which was the recipe, self-hosted searching. So I will just maybe do that next time. All right. Rio, low-key hesitate. Just jump into one, you know. Just don't. If you do get stuck, you know, maybe that just means you just gotta learn a little more about the programming language, and you just do both along the way, and you're good. You should be good. All right. I'll catch you guys later. Thanks for joining, guys. Peace.